graph are going to have the coordinates here listed in purple. And when we graph it, we're going to come up with a pattern of 0, 0, high, 0, low, 0. That's where we're getting our hollow from. And we can connect those. It's going to repeat itself every 2 pi. Okay, let's look at when we multiply by 2, it's going to stretch this thing. All right, so at 0, we still stay at 0, but at 1, we're multiplying by 2, so we're going to go up to 2. Stay at 0, down to 2, 0, up to 2, 0, down 2, and back at 0. All right, so connect that curve. Stretch the amplitude. The amplitude stretches your graph. All right, so what's the 1/2 going to do? What's it going to do to our y values, the 1/2? You can answer me. All right, it's going to take half of your y values. So we're going to have 0, 1/2, 0, negative 1/2, 0, 1/2, 0, negative 1/2, and 0. Notice that pattern is still repeating. We've just smushed our graph down some. All right, so the 0 stays 0, but we're going to half the height. And connect those. So it's like taking little short breaths. All right, let me stop this for a minute. I want to tell you a story. So, all right, this is our sine graph. So what A does, all right, it stretches it, right? So if A can stretch it or shrink it. So look at the questions on the bottom of your page there. All right, let's skip down a bit. So look at the third question down. What do you think if I had y equals 3 sine x? What happens? What would the amplitude be? On the third question down on the bottom. You with me? A is 3, right? So instead of at 1, what's going to happen to my height? Goes up to 3. What if we made that a negative 3? What would happen? You flip it over, right? Instead of hollow, you're going to have 0, low, 0, high, 0. Oh, low ho, right? You got to say it with a deep voice. Oh, low ho. How low can you go? All right, what's going to happen? Look at the fourth question. What would happen to the graph if we had y equals sine x plus 1? It would move up. It would shift up. The whole thing would shift up 1 off of the x-axis to y equals 1. All right, we're going to be doing that later on in class. All right, notice here the period, this thing repeats itself every 2 pi. That's why this period is said to be 2 pi. All right, let's do the same thing with our cosine graph. So using your unit circle again, just like we did before. All right, let's go back and look at our unit circle again, our blank unit circle. All right, so at negative 2 pi, what's my cosine? When I say cosine, you say x. So it's 1. At negative 3 pi over 2, at negative 3 pi over 2, my cosine is 0. All right, so go ahead and fill out that chart using your unit circle. Okay, so I've got 1, 0, negative 1, 0, 1, 0, negative 1, 0, and 1. Everybody okay where I got those numbers from? Just going on my unit circle. At 0, I would start going counterclockwise in the positive direction. Because these are angles, right? Yeah. Yeah. All right, so let's graph. Everybody okay on that? Let me go too fast. All right, so at negative 2 pi, we're at 0. I'm sorry. Nope, let's do a 1. At negative 2 pi, we're at 1. At negative 3 pi over 2, we're at 0. At negative pi, we're at negative 1. At negative pi over 2, we're at 0. At 0, we're at 1. At pi over 2, we're at 0. At pi, we're at negative 1. At 3 pi over 2, we're at 0. And at 2 pi, we're at 1. All right, so here's the cosine curve. All right, what's my domain? All reals. What's your range? Negative 1 to 1. So that means we're never going to have a cosine of x equals 3. Okay? Or cosine of x equals negative 2, because the range is between 1 and negative 1. All right, what's the period? When does it start repeating? Looking at 0, when does this thing repeat its pattern? At 2 pi, right? The period of sine and cosine is this thing. It's going to repeat itself every 2 pi. Or it looks different, right? So it starts, instead of starting at 0, like the sine graph did, this starts at 1. All right, so what do you think this little shortcut to remember this is? We're high, 0, low, 0, high. Holla. That's the way I think about it. Holla. Okay? We do. We have a good time, too. You haven't partied till you math partied. Oh, don't. Yeah. Don't derive and drive. No, no, that's not right. I gotta get the joke right. But there's a joke with derivatives. Yeah, don't drink and derive. That's what it is. Yeah. Okay. Scratch that from the thing. It's gonna. All right. Okay. Let's finish this. Come on. All right. So when we so our altitude is 2. That means all of our y values get multiplied by 2. So 2, 0, negative 2, 0, 2, 0, negative 2, 0, and 2. That pattern is going to stay the same. High, 0, low, 0, high. We're just going to stretch it up to 2. So we're going to start at up at 2, 0, down to 2, 0, up to 2, 0, down to 0, up to. All right. So that's a change in amplitude. So what's the amplitude in our third graph? 1/2. All right, the last one. So this time we're going to be halving our y height. So it's going to be 1/2, 0, negative 1/2, 0, 1/2, 0, negative 1/2, 0, and 1/2. All right, so let's do that. So we're going to halve those heights, keep the zeros the same. So here again is like a little shallow breast.